In the next several minutes, I'm going to teach you everything there is worth knowing about bend quality, diagnosing bend quality and performance-related issues on a RogueFab bender, and even talk about the tooling differences between RogueFab's tooling and the competitor's tooling. For example, bend quality, 14%, huge problems. Smoking gun, there's issues. And this is mandrel, 1.5%. It's almost technically perfect. Let's get into it. Let's start off with the design differences in the tooling between RogueFab and the competition. So you guys probably already know about RogueFab's tooling. This is one of our bending dies. There's an entire wall of them behind me. We inspect them and wrap them. We inspect every single one of them with precision profile gauging to make sure they're in spec. They're of course all made in the USA from domestically produced Kaiser billet, which is awesome. And these are round profile dies. I'm not talking about the obvious here. It's a circle. But I'm talking about the actual profile of the bending die itself, the part the tube contacts while it's being bent. They are truly round. And while that may seem super obvious, the other tooling is not. I'll show you guys that detail in a second. One nice thing about these being a full circle die is every time you bend, it's going to be in a different place on the die. And so you're going to have 360 degrees to make a bunch of 90-degree bends or 45-degree bends. So out of hundreds of bends, you're only going to have 20 to 30 wear spots on each location around the die, randomly distributed. So they do last a very long time. The clamps are separate on our tooling, so the clamp can actually pivot in the machine on this pinhole right here relative to the bend. What that allows you to do is put bends back to back, touching in opposite directions. We call them S-bends. They're in other videos, so check the link in the description. We'll have a couple different videos down there. Now, let's talk about the other tooling. So this die was made by JG², and there's a whole bunch of dies that are very, very similar to these. Some of them are interchangeable, but that's not the focus of this video. I want to talk to you guys about profile. This is a 1 5/8 die, 6.5-inch radius. That one I just showed you that's ours is a 2-inch diameter, 6-inch radius. So the bend starts where this clamp is, which is one of the biggest differences. The clamp's welded to the die. On some imports I've seen these crack, but again, not the focus of this video. I've never seen one crack on this brand. These dies have a non-round profile. Obviously it's round this way. The bend will always start right by the clamp, so most of your wear is going to be right at the beginning of the die. But this part at the end has very little wear, and you can see how they machine the die. It's got a V shape to it, or a parabola. I'm not here to give you guys a mathematics or algebra nomenclature lesson or condescend to you. I'm going to call them V dies for short. But basically, it's pinching right in here on the bottom of the bend or the inside of the bend. And what that does is it puts a little bit of compression on the tube, reduces the deformation and tension on the outside, and adds some on the inside. So you basically get 3 kind of areas of deformation, but they're all very small. Works extremely well, works well on thin tube. The bends look nice. They measure well because every kind of flat has a point opposing, kind of like a rotor in a rotary engine. So they work really well. And interestingly, since the bend always starts where the clamp is, that's where the most wear is. This is a used die. And you can actually see that there is less gap where it started. The steel that tubing is made from is pretty tough and pretty abrasion resistant, more so than the hot roll that I'm pretty sure this is cut out of. And so they do wear a little bit. They last a very long time. We're talking about like sand eroding a building. So don't be concerned about the wear no matter which style of dies you have. They last for hundreds if not thousands of bends. The other factor with these dies is you will almost always see the V-shaped dies on a larger radius. Ours is a 6-inch radius. This one, if it was a 2-inch, would be at least a 6.5-inch radius. So they're usually in a larger radius. That helps with bend quality as well. We mentioned where those dies are going to deform the tube. Where the RogueFab one is going to deform the tube is all on the outside. So even on this horribly deformed bend that is a problem, which we'll explain how to diagnose in a minute, the inside is actually really nice. There's no like flat spotting on the inside at all. This bend did not come off of that JG² die. We machined a die with an exaggerated V groove so that I could show you guys exactly what it looks like. It still has the flattening on the outside, but when you turn to the inside, there's actually a noticeable kind of flat spot off to the side from the actual inside of the bend on both sides. And this is, again, is exaggerated to show you what profile you're looking for when you're analyzing them. But the cool thing about this design is every time you grab a point, you're opposing a flat in all 3 directions. Rotated, 120 degrees around the tube 3 times. So the sweet thing is it mics out or measures out to be almost nominal everywhere. This bend is 7% deformed, just measuring from this flat to the inside. This bend is a bigger diameter, but it's 14% deformed, and they look the same to me in terms of bend quality. But it's all because of that kind of ridge or artificial kind of bump on the inside created by the V-shaped die. So it measures out extremely well. It is taller in section than, you know, one that's deformed more, so it's not bad by any means, but it is interesting to see the way they move the deformation around the tube. There are ways to get around deformation, and they are by using more tooling and more options. There's a reason why the multi-$100,000 mandrel benders have perfectly round profile tooling and a whole bunch of attachments and variations in the way they can be set up. Our machine has a few variations in the way it can be set up and a few tooling options, so we're going to go over those a little bit later in this video. Before we get into diagnosing what can cause poor bend quality on your RogueFab bender, I want to show you guys a range of bend quality and talk a little bit about wall ratios. So bend quality is measured as a percentage. You've already noticed me calling it that. And the reason we do that is because if a 1-inch tube is deformed by 1/8 of an inch, that's like 12.5%. It's pretty gross looking. On a 2-inch tube, that same amount of deformation at 1/8 of an inch is barely over 6%. And it looks pretty good. So a 6% deformed piece of 2-inch tubing would be, well, this one's actually 7.8. And it looks pretty darn good. But it'd be 12%, which is almost this flat if it was on a 1-inch tube. So we're going to go off of percentages. There's an easy way you can calculate your percentage deformation. All you need is a pair of calipers, like this cheap dial set. They're about 20 bucks. You won't be able to get away with using a tape measure. And take those and go to roguefab.com/bend quality. You can also go to roguefab.com/tech and see all of our free calculators and design tools. But there's plenty of information there in the tech or bend quality sections to give you your percentage deformation, your bend feasibility estimates, and also calculate your wall ratio and your D ratio. Those are more ratios that we care about. Just like how deformation is going to be measured in percent, our wall thickness when we're buying tubing is a decimal, like 120 or 0.83. But when we're talking about is this tube thick or thin, it's wall ratio, which is, of course, the material's diameter divided by the wall thickness. Now, you don't have to memorize all these numbers that we've got typed up for you, because you can get them very easily off of our webpage. You can type in your own numbers, get your own wall ratios, get your own D ratios. So the wall ratio is, of course, the first one I mentioned. 2-inch tube, 100 wall, that would be a 20-to-1 wall ratio. 2 divided by 0.1 gives you 20. Anything below 20 is relatively thick, kind of average in the high teens, gets really thick when you're getting close to 10. Anything in the 20s, 30s, 40s is considered extremely thin for wall ratio. So the other one is the D ratio of the die. That is a measure of how tight the bend is. So, for example, I've got a pretty tight bend over here. That's the 4-inch. This is 2-inch bent on a 4.5-inch radius. So what is that, a 2.25 D bend? It's extremely tight. Anything below 3D, which would be 2-inch on a 6-inch radius, which is what that is considered tight for non-mandrel bending. So anything below 3D, tight radius. Anything above about 17, 18 wall ratio is considered thin. You can get away with having one of those ratios be kind of bad. As long as the other one's good, you'll get decent results. The problem is when you're greedy and you want both of them to be bad. I have some really cool examples that show when both those are bad, we were actually able to pull off pretty good results with one of these machines. I'll show you a little bit later in the video. So some example D ratios are 1 3/4, 6-inch radius, extremely common one. That's a 3.4 D bend. But again, you can get all these at roguefab.com/bend quality, type them in and see exactly where you are. That also has a bend feasibility commenting feature built in, where we've actually programmed comments based on what you type in that'll say, hey, this is below 2.5 D or below 3D, expect it to need a mandrel, or you won't have good performance unless you do, that kind of thing. So it's a really great tool. Let's get into some of these bend quality things. We showed you the 14% deformed 2-inch, huge problem. I'll get into exactly how that can be caused soon. What you would expect to see on that, 2-inch, 120 DOM, this is 10% deformed. This is what we expect to see with no additional equipment in this bender. This is the minimum rated for this die. It's exactly a 3D bend, and the wall ratio is just below 20. So it is pushing the limits on both of the ratios, which is why the bend is pretty flat. I don't love the way it looks. Anything that has that level of deformation, 10% or so, on our webpage, we're going to do our best to put a warning message on that. I know it's present on almost all of them already that says, hey, you should consider blank. Thin wall roller, mandrel, something else. If you go up in wall thickness but keep that same diameter, your wall ratio gets better. D ratio of the die is the same. This is 188 wall bent on a 6-inch radius. It's 2-inch. It's deformed about 7%. It looks good. Most people think 7% is just perfect. So that is true until you see something that is better. Keep going up in wall thickness and you're going to get a bend that looks like this. Now I said wall thickness, it's actually kind of not true. This is a solid piece of rod. Since it cannot collapse, it is going to be 0% deformed. It's a perfect bend. But no one wants to really fabricate with this if you're doing anything motorsports related. So how do you get even better bends than that? Well, the first step up is a thin wall roller. This is a solution to reducing deformation in bends that does not require the expense and size of a mandrel. And we've recently made further improvements to this to change the pressure die out in the front. If you've seen that or want to know more, just go ahead and email us. We're actually doing free upgrades for people based on certain criteria. You just have to place an order with us and we'll ship you one for free if you've already got a thin wall roller from us with the older front roller pressure die. These ones are fantastic for aluminum. These ones further improve on steel, these friction ones in the front. This is adjustable, patented, it's made out of tool steel. It's a fantastic piece. But if you're using the thin wall roller on 2-inch, 120 wall, that is with this one right here. This is 6.8% deformed, so it looks as good as the super thick wall that no one wants to use for motorsports work, and it looks substantially better than the 10% deformed 120 wall with no thin wall roller. This is the same material, 120 wall. Going in that same direction, doing it again, this is deformed 1.5%. This is the same material, 2-inch, 120, 1020 DOM is the alloy, bent on a 6-inch radius, 1.5% deformed because of the mandrel. So there's the three side by side. From your right at 10%, no mandrel, no thin wall roller. The middle, thin wall roller, and 7.8% deformed. And then the one on your far left, mandrel, 1.5%. So that is the full range of what you expect to get. All exactly the same alloy, same OD, same die, same everything. We've been experimenting with the mandrel for a long time. We've pushed it quite a bit further than that. We've done some other ones I want to show you guys real quick. This is done with some experimental tooling. This is 2-inch 065, so this is really in the realm of exhaust pipe, and 6-inch radius, and it has 1% deformation, actually just under 1, it's 0.9% deformation. So it's mathematically just about perfect. Doesn't get a whole lot better. We've done some stuff even beyond that, like I showed you this one earlier. This is a 4.5-inch radius. This is done in a regular production mandrel, and deformation is 4%, so the bend looks nice and really, really tight. And then we even did, this is, I describe it as razor thin. This is 2-inch 043. Probably sold as 045, T304 stainless, so it's very, very prone to wrinkling, which is why there's a tiny, tiny bit of wrinkling in here. This is into the neighborhood of plumbing. I mean, this is no longer structural. It's 043. It's a super, super thin. Bent on a 5-inch radius as well. So this is violating wall ratios at 47 for bending without a mandrel. That's why it was used with the mandrel. 47 is insane thin, and it is a 2.5D bend, so it is actually a pretty tight radius. Even with a mandrel, 2.5D with a wall ratio of 47 is a little tight. So even the multi-$100,000 mandrel benders will sometimes leave a little bit of these markings on the inside, but they're not super deep. They catch the light a lot because it's stainless, but this tooling is not actually for sale to the public yet, but we've been experimenting with it, and I thought it would be relevant to show it to you guys in this video. Anybody who does fabrication in the boat and marine world is probably thinking, what about non-ferrous alloys? Don't worry, we got you covered. These are both aluminum 6061 T6, so the brittle temper, and it is 2-inch OD, 1/8-inch wall aluminum. This is straight off the machine, no upgrades of any kind, and it is 12% deformed. It's not pretty. This is an application where we would definitely recommend a thin wall roller. Just drop that in, one pin mounts it in, it replaces the pressure die, and you get to drop it right down to 6.7%. So this bend is nice and round on the inside and the outside, so looks very, very nice. And we also can get even further than that by doing mandrel. Mandrel bending does work on aluminum. It does work in our machine, and we've got an extension so you can bend full sticks right in the middle. I'm saying that because 2-inch 125, 1/8 wall, is really commonly used with aluminum on boats to do wake towers, bimini tops, that kind of thing. And when it's up high on display on a boat, it usually has to look as perfect as possible. and that's what the mandrel is for. Now, you guys have been waiting. I want to show you exactly the 3 common causes that can make bend quality problems occur in a RogueFab M600 tubing bender. The good thing is there's only 3 of them, and they're pretty easy to figure out. I'll list them and then tell you in detail. Clamp block slipping is number 1. Number 2 is material issues, and number 3 is incorrect machine setup. So let's jump into the details. Clamp block slipping. That does not mean you have to go more gorilla tight on the bolts usually. When your clamp slips on your tube over and over and over, it will basically burnish lines into the clamp. The problem with those lines is they are going to promote slipping and hold grime and dirt and oil, and it's just going to keep slipping. So the solution is you recondition your clamp block. If you go to roguefab.com/bend quality, I know we keep dropping that web address, but it's really relevant. It'll teach you exactly how to condition these with emery cloth so you get the ridges in the correct direction to oppose the sliding motion. Once you do that, they will not slip as long as you clean your tube and the clamp with lacquer thinner, acetone, or some other type of evaporative degreasing cleaner. And they grip extremely well, even if you're bending super thick stuff. We bent this solid bar with a single clamp with just a regular 8-inch long wrench, torquing the bolts. So if you find yourself grabbing a cheater bar, that is an indication that there's a problem. This machine is not testing your strength or the strength of grade 5 bolts. They're grade 5 for a reason. If you break them, it's an indication that there's something going on. Number 2 is material issues. These range a lot. The most common material issue is being sold material that is not within spec because you either just didn't get delivered the right material or because the material is actually made wrong. On steel, we have actually had a customer who went through a diagnostic process with us who had material that was thick at the ends, like 0.95 wall 1 3/4, and in the middle it was measuring 0.78. He cut a stick, measured it in the middle, and it was actually thinner by roughly 20 thousandths of an inch. So I don't know what caused that, but it was DOM steel, it was made in the USA, and that guy was so upset when he found that out. He went straight to the supplier and obviously returned the material, and they took it back. When you're measuring a material, you got to deburr it, measure it with calipers, not a tape measure, and you're going to measure it in a few different places at both ends of the tube. And then if you've cut the tubing up and used it, measure the ends of some other pieces from the middle of the stick as well. Your material will not usually be nominal wall thickness, like 120.120 inches. They usually come in at like 119, 118, and that is completely fine. If it's under by like 5 or more thousandths, it's a problem. You may have been given a different spec of material or something else, and you should definitely consider evaluating that. If you have other material problems, they can exist on aluminum. So aluminum is usually extruded. So there's a piece in the middle, and the material is being pushed through a die, and that piece can actually float a little bit off center, and you can get a wall thickness that's thicker at one side than the other, as opposed to the steel we've seen where sometimes it's thicker at one end of the tube than the other. So you will almost always have a variation with aluminum. If it's a few thousandths of an inch, no big deal. If it's 20 or 30 thousandths of an inch different between side to side, which I have actually seen, again, you're probably going to have to go back to the supplier and address that with them. Aluminum also can have a tendency to crack. If you want to learn more about how to avoid cracking, we've got an entire video on annealing aluminum. The link to that will also be in the description. So the third cause is machine setup. Thankfully, there's not a whole lot you can get wrong on these. The most common mistake people make, and these do ship with clear color instructions to tell you everything you need to know. The most common mistake people make is they will take their pressure die. Here's a regular friction pressure die, which goes on this pin right here. And instead of putting it in the front where it goes, they'll put it in the back. This is labeled HD, never use on 120 wall or thinner. Now, if you're mandrel bending on a 6-inch radius, you will use that, but that's deep into like detailed setup for mandrel, which is advanced. Those people almost always read the instructions. Guys will sometimes throw these in here. Maybe they bought the machine used, lost their instructions, whatever. Call us, email us. We'll get you brand new instructions, or we'll help you solve the problems. But the most common setup issue is they'll put a pressure die back here only, or back here additionally when they're doing thin-walled tubing. Now, we label every single machine to tell people not to do that, so we try to make it unavoidable. Accidents happen, it's part of life. Just give us a call and we'll take care of it. We'll walk you through all of it. So we've got those 3 issues. If a person gets through all 3 of those, which are of course, the machine setup, the material, and clamp block slipping, and none of those are the cause of the problem, you're in a very small group of people. We've had that happen 3 times out of thousands of machines in over a decade of selling these and servicing them and diagnosing them. And all 3 of those times, we traded material with the customer. So we said, hey, we've got 1020 DOM, it bends. We send it to them. They send theirs to us. Their material wrinkles in our machine. Our material bends beautifully in theirs. And they say, do I have to buy my material from Oregon? No, because we're in Oregon. No, you don't. It's not that hard to do, but it does take some time and some diligence. You will have to go to your supplier, commit to buying however much you want to buy, 20 sticks, 5 sticks, whatever you're going to buy. Tell them you want 1 for testing. They'll look at you weird and say, no, 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 no. Explain why and how your experience has been. Take the stick home, bend it. If it bends well, record the lot number, go back, get the rest of your delivery from that exact lot, from that supplier. That will solve all of your problems, and your results will be just like your testing, exactly the way you want it to be. If it doesn't work out, you're going to have to keep bouncing around and find the material that does work. So I have never found a way to track consistency with bending problems like that to country of origin or alloy. I've seen it with HRW and DOM over the years. It's very, very, very rare, but it does happen every now and then. We chose 2-inch material because we had the greatest range of testing, and it's our R&D size because we can push the limits on wall ratio. Like I said, 049 wall is not that thin for 1-inch tube, almost a 20-to-1 wall ratio, but it's extremely thin for 2-inch. It's almost 40-to-1, so it's crazy, crazy thin. It's actually just over 40-to-1. So we've got some stuff that some of you guys use more often here. This is 1 5/8 083 4130 chromoly. All you drag race guys are like, finally. So yes, this is the material you use. This is everything but a handbook for NHRA or other go fast straight line cars. So the handbook guys are going to be using 120 wall mild steel, probably still DOM. This is for stuff like SFI cert, so like the 6-second cars, the 7.5s, SFI 25.5, 25.4, all those. So this is that normalized 4130 chromoly. This was made by Plymouth Tube, I believe, and this is what we would expect to see for bend quality out of this machine with nothing else being added. If you're buying this die on our webpage or a machine with this die on our webpage, a little message is going to pop up and it's going to say, hey, if you're bending 083 wall, which we kind of know you are, we recommend you buy a thin wall roller to go with it. If that's the only thing you're interested in and you have to have the performance I'm about to show you with the thin wall roller, just budget that in. Like I said, lots of machines, especially advanced machines like mandrel bending machines, have a lot of options for tooling and a lot of options for machine configuration and setup. This is 10% deformed. If you don't like that the way I don't like that, that is fine. Get the thin wall roller. This one is 4.9% deformed. It is gorgeous. I love the way it looks, and if I had this or the option to spend more money and more setup time and mandrel bend it, I would do this because it's easy and I like it. It's good enough. So the inside is still gorgeous. There's no V-shaping to it. There's no hip or transition here. I mean, I can see it, but I've been doing this a while. So there's a tiny little hip transition. The V-shaped die, since they V into it, there's a lot more of a hip here. So this is actually a really, really nice bend. And it's 1 5/8 083 chromoly, 6-inch radius, bent with a thin wall roller. And this was done with our newer friction pressure die, which I mentioned earlier. If you don't have those and you want them, email us. We'll tell you how you can get a set probably for free from us. So now you've seen the performance for 4130. Well, most people just call it 4130, but it's 1 5/8 083. This bend, if it was done with a mandrel, you could get it below 1% deformation in this machine on a 6-inch radius. And if you did a 4.5-inch radius, which may or may not be allowed by your racing regulatory body or your inspectors, you could still keep it under 1% deformation. So the ratios are really, really outstanding. Some other cool stuff we've done was the 304 stainless. So this is 304 stainless, 5-inch radius, 2-inch diameter, so kind of nasty wall ratio, and this was 043. I'm not sure what it was supposed to be, but it mics out at 043 wall, so it's wild thin. Bend quality is super good. It's actually 1% deformation, but the real flaws are the tiny shallow wrinkles in here that grab light and don't look great. So this would be for exhaust anyway. It'd flow real well, but not as tight as the elbows you'd buy from like Summit Racing, the little tiny ones. If you have a machine that's not a Rogue Fab, me telling you all these cool features and innovations and what we're patenting is not meant to tell you that you bought the wrong machine. If you have a bender and it's doing what you want, you bought the right bender. If it's ours, great. If it's someone else's, also great. One other thing is, if you're having any problems with bend quality on this machine or any other machine, find the manufacturer's phone number, give them a call. They have seen the problem before and they will walk you right through it. When you call Rogue Fab, we pick up the phone, usually within the first ring or two, and if we miss a call from you, we'll usually call you back without even getting a voicemail. So we're available. We're also available via email, and we've got more tech articles on our webpage than any other manufacturer provides, and that's been that way for the last 10 years. So check us out at RogueFab.com, subscribe, comment, and if we left anything out of this video, we try to cover it in great detail. Leave a comment down below. If you learned something, tell us you learned something. We'd love to hear from you. Thanks for watching.